Hello, everyone. Thank you for being here. And if you are not part of the live session, but you're just part of if you're just watching this later, then also very welcome. And what we're going to be talking about today are 3D models and textures, and especially patterns and structures that you might find in nature. And what I found is that when I'm generating my models, I always have to balance the quality of the model and the sort of the weight of the model, and that means the resolution of the poly counts, but also of the textures and the materials. And ideally, you would render everything as high quality as possible without having any compromises. And so over the years, I've developed different tools to get there. And some of them I think will be familiar, but I'm using some tricks to make everything as efficient as possible. And so first we will be building these tools that generate the models. And after that, we will use the new Copernicus system to generate textures. And you can use those textures on very low resolution geometry. You can use them in interactive situations like Unreal Engine, or you can just render them. I used instances before, and instances, of course, also work. But what I was trying to do here is to just keep the geometry as light as possible while still keeping very high quality models and textures. And yeah, so I'll just get into it. But before we start building models, I'm just going to talk about the viewport in the desktop for a minute. All right. The first thing I always do is to make this the sort of the dark background. And it has to do with that I use a lot of very thin geometry, thin lines, and I want to see all the textures and the attributes. And so what I do is that you just press D on the viewport, and you should see this display options, and just go to background and set it to dark. And that way your background is nice and dark. It will be a lot easier to see the models that we're creating. One other thing that I do most of the time, and it will be useful in this session as well, is to split these viewports. It will come into play a little bit later, but if you could just follow along and split these the way I do, where you have this here, this button on the right, you can split this pane left and right, also at the top. And if you see here, there are these numbers. With you, it might look like this pin here, but what these numbers mean is that these panels are rendered or running over here. So what I want to do is to make sure that the panels on the left have the number 1, so that whatever we're viewing here, we're viewing in the viewport. And these over here, set that to 2, because it allows us to have a little bit more parameters and a little bit more control without having to jump back and forth different screens. All right. Now, when we've done that, I'm going to start building nodes. Okay, so we'll just create a geometry network, and I'm going to call it leaf texture. So today we'll be building a leaf, but a lot of these techniques, you can also use them to build petals and anything that is flat. I use this for, and it can also be extended to more 3D objects, but I make a lot of petals and leaves for my model, so I had to create these different tools to create these. So we'll be creating leaves, so that's why it's called the leaf texture. And when you go in here, first let's create a grid. Let's make sure it has quite a lot of quite high resolution, so 200 by 200. We might change this later, but this is good for now. Yeah, and so what we want to do is to basically have a clean base grid that we can shape into the shape of our leaf or petal. The way to do that, I think the easiest way is to use this linear taper node. So just linear taper. And this just allows you to deform your object based on just a very sort of linear deformer. Now by default, the settings are not quite right. So you can see it captures only half of our object. So make sure that this capture origin is set to -5, and then the capture length is set to 10. And then if you play with this taper here, you can see that you can start shaping your grid. But if you click on this ramp here, you should be able to ramp it in a much nicer way. This is, of course, quite linear. So what I'm going to do is just delete these points and turn these into Bezier points. I think we only need 2, and just create a very nice organic shape. And what is great about this setup that we'll be creating is that actually this shape here, they're going to make it red because it's so important. This shape here is going to allow us to deform all the different textures and objects. So this is the part that makes it very flexible. I think we'll get back to it in a second, but you will see that this will be our most, I call this grid leaf shape. And this will be our most important node to generate our different models and textures. And you'll see how we do that in a second. On the other side, I'm just going to create a line. Lines are the best because they're very simple geometry that are very light and always interactive to edit, and they allow you to really have very fine control over your procedural models. So what I'm going to do here is to make sure that the direction is the same direction as the grid. I'm just going to reference this, and which is the Z direction. And the length doesn't really matter because we're going to fit this to the shape in a minute. But just make sure that the direction is set to the Z axis. Then I'm going to use a match size. And you can use this to scale an object based on the second input. So that will be our leaf shape. And then if you click on this scale to fit and then set it to the Z axis, then the line should be exactly in the middle of this leaf shape that we created. Yeah, I think that's it. Let's see. Okay, yeah. What we're going to do now, so we have our middle line, and what we're going to do is to use the Houdini branch tools to generate sort of the structure of the leaf. Very easy. First, make a labs tree trunk generator. And what that is looking for, I'm just going to unreference this leaf shape here. But what that is looking for in the second input is, the first input is the drawn curve. So that means the curve that we created here. So I'll put that in. And what you'll see is that it'll create our shape, but it snaps it to the middle here. And that is because of this snap to center setting here in the tree trunk generator. So I used these in the first session as well, and because they're a very intuitive way of creating our shapes. And what I love about these is that they generate two things, two outputs. The first here is the mesh, right? So this is a mesh it generates. It has some noise and other things on top that that's not really relevant for us now, but you can use this to generate a mesh. But on the other side, I'm just going to call this mesh. On the other side, it generates my favorite type of geometry, which is a curve. Now, this line doesn't seem very exciting yet, but it gets better if you start to add labs tree branches. And so you can just connect these first and second inputs here, but you can also use this null object here. And what you will see, I'm just going to call this trunk and create a new null object just to visualize what it's doing. Call this first branch. And what you'll see is that if you plug this in here, that it's generating these sort of leaf lines, and they have a lot of different tools here, the angle of the branches and the length, and of course how many there are. And so you can use this to create the geometry of the leaf. But one thing that is not great here is that they are all pointing all kinds of different directions. And to make sure that everything stays on the same axis, you can use this custom up vector and set it again to the Z direction. And then instead of making the branching pattern 137 degrees, make it 180 degrees. And then what did I do? Oh, wait, yeah. I think what's happening here is a very interesting feature of the tree branch generator, which is this detangle option. And if you turn that off, you will see that they are more aligned. And then the other, oh yeah, sorry. Okay, that was the wrong up vector. Up vector should be Y in our case. Yeah, and make sure that this detangle is off. Otherwise, it's going to try to untangle our lines and it creates this unpredictable behavior, which I don't like. So make sure that this detangle is off. And so we have a few lines here. And what you'll see in nature is that even though there's a lot of detail, the patterns are actually quite almost mathematical. It's a very fascinating field of study, like the Fibonacci sequence and everything. Don't get me started because I'll talk about that forever. But what we want for that is to have very predictable and quite, let's say, mathematical distribution of our clones here, of our lines. And when you start increasing these branch nodes, it's using, I think, yeah, it's basically generating points on this line, and it's not always very, how to say, mathematical again. But if you change this placement node from scatter to edge length and then decrease it, you will see a much more predictable pattern here. So now we're already getting pretty close to a skeleton of a leaf. You can use this length ramp to change the length, and you can use this branching angle to angle our curves. And they should all stay completely flat, which is what we're looking for. So in our first session, I talked a little bit more about how you could change these shapes. I'm not going to go over all of the features. I'm just going to use a few of these. You can follow along, or you can make your own shape that you like. Yeah, but for now, I think what I want is to have just a few of these lines and branch them up a little bit and make sure that you can choose where they start to grow here. And I think also at the end, I don't want them to be too long. So what we're looking for is a rough structure here. It doesn't have to be perfectly aligned to the shape that we have, to our leaf shape, because we're going to do some magic in a second. Yeah, but there's all these different tools here. Tropism is also nice, sort of to curve our, I call them bones. I don't know if that's the right word, probably not, but I call them the bones of the leaf. Yeah, so some different ways of shaping these, right? And what I did in my Instagram post, which I just wanted to show you one other feature, is that if you just copy and paste this again, this tree branch generator, put these first branch here and here, it's going to generate even more. I'm going to copy this null here. Second branch. These are a bit long. Let's go to general over here and make them quite a lot smaller. So you get these sort of nice secondary branching shapes. And so you have this alternating shape, which is nice, but you can also here, instead of alternate on the second branch, you can set it to opposite. And then you get this, I think, more closer to realistic branching. I think that's the right word to use. And of course here, if you decrease the length scale, then you're going to get more or fewer branches. Okay. So I had this shape. Of course, I can make this. So what I did before was to try to fit it into the shape where you have like maybe the length or something. Maybe I can do something there, or yeah, I don't know. In the end, it's going to be not procedural if you're going to do this by hand, and it's not very flexible, and it's a painful process to go through. So after a lot of experimentation and getting very angry at my Houdini, I figured out a system that is actually a lot more flexible than I initially thought, and we'll just go over how to build that. What we're going to do is to fit our object that we created here into the UVs of this leaf. And the way that works is first you have to generate some UVs on the base grid. I'm just going to call this base UV. And you can just press this initialize button, and you should see that this little rectangle here now covers the whole shape. It creates these UVs. And so what we want now is to fit the UVs that are on here. I'll just show you. Or we want to fit this object onto the UVs, right? And actually, we want to do that before it gets deformed. I'll show you why in a second. So I'm just going to, instead of doing the leaf shape here, I'm just going to use this base. Should not change the shape at all because our line is fit to the base shape. Should be okay. So what you can do, actually, is transfer the UV attributes from our grid to our lines here. And if you don't use Houdini very often, it might seem like a very odd thing because UVs are used for shading and rendering and everything. But in Houdini, you can use the UV space to do all kinds of different things. So the way that works, and first what we have to do is to transfer our UVs from our base grid onto these points here. And there's a UV transfer node, again, labs UV transfer. And in the first input should be our lines. And the second input can be our base UV. So what it's going to do now is try to transfer the UVs that are on this grid here to these curves here, which it sounds like a little bit mysterious, or I don't know what exactly the word is, but just go with it. You'll see the way it'll work in a second, because now what we want to do is to give a command, and we're going to use one line of code to make it all work. But before we do that, sorry, we have to promote our UVs. To do that, you use an attribute promote. And what promoting means in Houdini is that basically you're going from one type of geometry to the other. So you have like points here and primitives, which are the faces and everything. So what we want to do is to go from our vertex, because UVs are generated on the vertices, and just call it UV, and change it into a point type attribute. UVs. So this is number one, and then here's number two, because we need to do that for both the grid here and our lines. And then what we can do is use attribute wrangle to have one line of code. I'm just going to, oh, you can put the lines in our first input and the grid in the second input. And then we're just going to use a very small line of code. I'm just going to copy and paste it in here and also to the chat so you can follow along. But we'll also build it together. It should be not the grid to the second promote, but actually our leaf shape. And as you can see now, our lines are fit perfectly to the shape of this leaf here. So if we now change the shape here, you can see that those lines, they are conforming to the edges of our leaf, right? I'll go very quickly over what this attribute does, but we can call this deform by UV, because that's what's happening. And so what this is doing is that it's going to change the position, right? The position of the first input here. And it's going to look at the UVs. So this is a command called UV sample. It's going to look at the UVs of the input one, which is the second input, right? Input 0 is the first input. Hope that makes sense. And then it's going to match the position to the UVs of the second input. I think I say that. I might have my terminology a bit mixed up, but basically it's going to try to match these two UVs together and then deform in that way, right? Apply the UV space onto our points here. And yeah, and so you can see that actually what I like about this type of deform is that it's really fast. It's completely interactive, and you can just create a base shape and play around with all of these settings here, especially this, of course, this ramp here, to change the shape of the petal or the leaf. And you can just take this tree branch generator here and you think, okay, for my new leaf, I want to have more of an angle or less of an angle. And you'll see that they are conforming quite well. They're being deformed, but actually that looks quite natural, right? It's like pushing it up. If you want to have more, you can have a lot more. And if you want to make the second, so what's funny is that when you select this tree branch generator, it actually has to load a lot longer because it's trying to generate all the mesh and everything, even though we just want to have the lines. So the generation of the lines is actually doesn't take that long. Anyway, so you can see here and you see all of these lines here. And what is great is that these are geometry, right? There's just curves. So you can use this to sweep them, or you can use them to do all kinds of different things. And just to put a finer point on how well this works is that you can even just put a noise on our leaf here, just a mountain noise, right? So this just distorts it, and you put this noise along vector. If you turn that off and then decrease the amplitude and increase this element size, you can see how nice this is deforming all of these lines. Like it really fills the shape and even goes in 3D, although we don't really want that in this case. But you could also use that 2D plane to distort something, or if you're very smart with UVs, you can also use it to project this on a 3D shape. Yeah, but for our case, this is all we need. And just one thing about this mountain, make sure that if you go to the amplitude here, turn off this noise along vector, because we don't want that in this case. And then in the amplitude, make sure that this second value here, you can press this button to split the amplitude into 3 different axes. And the second value, make sure it's set to 0. And that way everything stays flat, even when you're distorting it, right? It's still flat. This is, I would say, about half the magic that we're going to be talking about today. But I just want you to have this technique in your arsenal. I used it to create my own deform by UV. If we have enough time, I'll just show you how that works. But this is exactly what is up, what we just built, right? Just promote the UVs and use this deform. Inside is exactly what I just did. And it just deforms it exactly to the shape. This is not the cleanest model, especially these lines here at the end. That's not what we want, so we'll clean it up. Yeah, this is the deform by UV function, which I think is super useful, especially if you start to generate these type of very high quality models that are flat, petals and leaves especially. The clue here in how it works, excuse me, is the base grid, right? So this base grid is just a flat 0 to 1, let's say, so 0 to 1 and 0 to 1 grid. And so if you project your UVs on there, it's also very flat. And so that means that if you start deforming the grid, you're also deforming the UVs at the same time. So you're using the, as you say, like the deformed geometry, basically. Yeah, I think that's a good way of thinking about it. Yeah, but basically what is happening with this 3D geometry is that it's living in the UVs of this grid. And because it's flat, it allows us to very finely decide where the points go. It is very cool. I like it as well. A lot of my Instagram, sorry, a lot of my process is looking at nature and trying to figure out how to build those shapes myself. And yeah, I really like using these curves, sorry, these branches here to generate very organic looking shapes. And then after I found out that UV sample trick, I was able to, yeah, to really build very nice quality models because they have a lot of nice tools here, like this length variation, which is sometimes overtuned a bit, but you have all of this kind of subtle extra objects and sorry, extra settings here, and that might be useful. So you can both add detail in our leaf shape, but also in the branches that are coming in. And again, it's very fast, right? So you don't have to use, yeah, again, there's no simulation, or you don't have to use any of the deformer nodes, which are sometimes good, but not always great. At least to me, they're a bit confusing. And while I was talking, I was rebuilding the shape to something that is going to be a bit more instructive to what we're doing. Okay, so this looks fine. I like, maybe this is a bit too deformed, but we can change that in a second. But what I really don't like are these lines here. Should I use the annotation? Let's see. I think I just learned about the annotation with these lines, this part here, where this is not supposed to be here, but because our curves are out of bounds of the UVs, because our curves go out of bound, they get turned into this, they're basically conforming to the edges of our grid. So they confuse the lines and they're like, hey, we're outside of the grid, what should we do? And what they do is they try to follow the edge of the grid, which might be what you want, but it's not what we want right now. So we should clean them up. And maybe just to show you what I mean by that is if you have our lines here and then our grid, that our lines are overshooting the grid quite a bit. And instead of trying to correct the length here, what I want to do is to find a more sustainable way of cleaning them up. All right. So we have our deformed geometry here. And what we can do now is what we want to do now is to find sort of these edges, not of these lines, but of our leaf here. Then yeah, we'll go from there. And the most clean way of doing that is to generate them all the way up here before our leaf turned into a leaf and it was still a grid. So if you could just create a group node, and we'll call these leaf edges, and I think they should be points. And then turn off this base group and turn on this include by edges. And then you have this option here, the unshared edges, which is just like the edges on the boundary. So that's great. On leaf edges. And also, yeah, okay, sorry. I'll get there in a minute. And so what we want to do now is to select all of the lines or all the points that are on the edge of the leaf here, so we can delete them. And to do that, you can use a proximity node. And I'm just going to put our lines in here. And it needs like a secondary sort of reference input. What are the points close to? And to do that, to keep it simple, is to use a blast node, right? Blast is delete stuff. Put our leaf in there and go to our leaf edges group, and then click delete non-selected because we only want our edges. And this is also why in the beginning we use so many rows and columns. I think actually I want to have even more, I just want to have a lot of points here because I want to have a very good measurement of where the edges of the leaf is. And then if you put this here, the leaf edge points, and if you put it in a secondary input and run the proximity, you'll see that it creates this kind of interesting visualization. It creates an attribute that is sorry, the nearest point to these points. But instead of using an attribute, what we want to do is generate a group called nearby. You see that right now it's selecting a lot. If you decrease the search radius just a little bit, also would have it smaller, something like that. And so it creates a group called nearby. So now if we use another blast node, blast, put it in here and then choose nearby here. Okay, a little bigger. So finding this search radius. So basically what you want to have is a lot of points so that it's easy to calculate the closest point. And then what you can do is delete that line that was around there. And let's see, let's do before and after without the visualization. So no surrounding lines. And there you go. So now we have a very clean, again, like I call it, skeleton of the leaf. And just to test it, so it's not going to be, you might have to adjust some of these settings just a little bit, but most of the time it should work quite well. So sometimes they appear a little bit like here. That means you might have to increase the search radius just a little bit, but eventually you should get to a nice balance between deleting enough of them and still keeping the points very close. So yeah, so that's how you clean up this model. Now we have a pretty nice skeleton of our leaf. Let's see, do I have any other things here? Yeah, there's one extra step we can do to clean it up even more. I'm just going to, if we have time, we can come back to that. But I think for now we have a pretty good model. So I'm going to continue to the next step. Okay, so this is one thing that most people struggle with when they generate these type of models where you have the sort of the veins of the leaf. And because generating them can be, you can use different techniques. There's also the find shortest path. But this is, I think, a more sustainable and more flexible way of generating these type of structures. But there's one other structure that I saw in a very recent Houdini YouTube video, which is the sort of the cell pattern of the leaf. So let's generate one of those. And we're going to use a few different techniques together. But first we'll start with taking not all of the branches, but just these middle branches here. We go over this a little bit at the beginning of, in the first session. But when you create these 3 branches here, it's going to run this and go to the information here. Very small, but you can see that here it creates a group called trunk. And then here in the first branch creates another group. And probably it's called tree branch generator. And that's because it gives us the name of this node here. So what we can do is call this first branch. Is there another first branch? Oh yeah, call this something else. And it's call it fizz as well. And then call it second branch. And yeah, that's again one of those small features that I really like, is that it automatically creates a group that is actually the name of the node, which I think is always cool if that works. That just allows you to get away with making fewer nodes. So in here now we have a few different groups. The trunk, the first and the second branch, just to visualize that. I put a color in here, turn it blue. Also see the dark background working here. And if I go to these groups here, I can select the first branch, which is just these ones. And then I can select the second branch, which is just all these small ones. And this just helps you also later on with meshing or when you generate the attributes to just split things much easier. So we have those groups in there. So what I'm going to do is just use an object merge, keep things relatively clean. And I'm just going to put this second branch in our object merge. So I'm just going to give them the same color so that they are linked. Yep, and I'm just going to call this get branches. And you can just drag this null up in this object here. Okay, so now if you run this node here, then it's just going to collect these over here. And what I tend to do is just cut this node, Command X or Control X, I think. and just cut and paste and put it over here, because this is where we are going to generate our second shape. And to do that, we are going to take our leaf here and generate a fall off based on the branches here. And to do that, there's a node called a geometry mask from geometry. And actually you have to do this mountain. Should probably put a node in here as well. A node here on the mountain called leaf skin, right? So we have the skeleton that goes through the leaf, and then we have the skin itself. And what we can do here is to put our leaf skin in here and put our branches in here. And when you run this, it might be very slow. And there's a trick to make it go faster. The trick is very simple. Oh, wait, is this right? Oh, sorry. No, it's not these branches, actually. Of course, we need to use our deformed branches, which are these. So I'm just going to make a new node and call it deform. Probably even here. Why don't we use this one? Call it deformed branches. Right. So this is also cleaned up the edges here, and put that in this node. Now we have to make sure it's the right color. Same color. This one can be a boring color. Okay, so we have our branches coming in here, and then we have our mask from geometry. And you can see that when it's cooking, it's quite slow, which I don't like. I want it to be basically instant. And the reason why it's quite slow is that it's using the primitives, right? It's trying to figure out the fall off from each of these lines. And this is a more accurate version of this distance from geometry. And it is very useful if you use more 3D objects. But in our case, because we have a flat object, we can get away with just putting it 2 points. And then suddenly it's instant, basically, calculation. It's way faster. As you can see, if you increase or decrease this radius here, you can see our branch pattern show up as an attribute here, right? Or you can see like this mask that it creates is based on our branches. And again, this is why we need quite a lot of geometry here in our base grid. What we want to do is to find out where the branch skeleton exists and then where the branch skin exists. It makes sense in a minute. But what I want to do first is that I don't want to actually have the secondary branches, because if you look at nature, then the first branches are quite thick and they seem to bring a lot of structure to the model, or sorry, to the object. But then the secondary branches are quite thin, and to me it feels better if you can lessen the influence of the second branch. So what I'm going to do here right now is just use a reference group. Oh, sorry, I want to use a reference group, but there are no groups here. And because the group that we're referencing are points, and the groups that are being generated here by these branches are not points, they are actually primitive groups. So just like we did our attribute promote of our UVs, we can also group promote. So we're just going to turn these primitive groups, these lines, into point groups. And I want to basically do all of them, but let's just do one by one. Here, first there is our trunk, and we're going to call it trunk. Yeah, so you can see that right now these are points here. I don't know if you can see. Let me put these guys a bit bigger. Yeah, this is probably better. Something like that. So you can see that right now it's generating a group that's basically the same as this middle line, right? The trunk. And make sure that you click on keep original group, because we might need it later. These are things that you will forget, and then way down the line, you think, what happened to that group? I should delete it here. Okay, so let's do 2 more. 2 promotions. So we have this group, and then we have our second branch. These are, sorry, these. Give it the same name. And keep original group. Oh, sorry, this should actually be the first. That's fine. First branch, and again, keep original group. Okay, so now we have point groups, and we can put that in our mask from geometry, the first branch and the trunk. So you can see that right now it's not generating a fall off from these over here, just from the middle lines, which gives us a lot more, I'd say, like more room to play with in our gradation. So if you increase this radius, you can see that sort of creates this nice fall off. And by default, this fall off is set, it goes to, like, it's like white to red, right? But actually, we can just make a very quick color node and ramp from attribute and mask in here, and you can see it also goes from black to white. So you might see that you have like these kind of gaps over here. If that's clear for you to see. you have like these gaps where you don't really have enough resolution of the points that are coming in. And so what I think you can do is just put a subdivide node in between these, and now you have a lot more geometry to sample. Okay. The way I use Houdini is I'm trying to imagine Houdini as an imaginary garden where I'm growing my own plants and my own leaves and or my own flowers. And so I see this as the strength that a skeleton can give to a body. It can also give that to a leaf. And so I like to generate this type of maps to drive different things. So this is one way to do that with this mask from geometry. So what we're going to be using this mask for now is to scatter some points. And so you can use a scatter. It's a simple scatter node. This mask from geometry. Let's call this generate line all maybe. And then if you go to the scatter, so by default, it just scatters a bunch of points. But if you set it, if you click on this density attribute, going to look for an attribute. We could call this mask, but we can also just change this output mask and call it density so that they are linked better. And now when you go to the scatter node, you'll see that it's only scattering where the mask exists, right? So if you increase this, you will see that they get closer or further away from our skeleton, basically. And that's also nice. You can just create a lot of them. Yeah, you can play around with these. And I put this on my Instagram yesterday. I really like looking at these patterns, right? So you have a lot of them. You can just, if I ever don't respond to your DMs, this is what I'm doing, looking at these patterns forming themselves. And we don't need quite as many points. For now, I'm just going to do 100. We will increase that later because you can use these points to generate a very nice looking cell pattern. And there's a node for that called the Voronoi fracture. And you can just, yeah, I think you can just put this one in the first input, just our leaf skin with our attribute inside. And then it needs points in the second input, require points for the Voronoi cells. And if you put that in here, it's going to do something. You can see that already looks quite nice. And when you run this, it looks like a mess, but we can clean it up by using, again, a blast node to basically delete everything on the, I think it's on the outside or on the inside. It's on the outside. So now if you look at our point structure here, you can see that there's this kind of interesting pattern forming. Now, oh, and then if you use a polypath node, you can actually see it. So now we have a cell pattern here. Now, the first intuition that you might have is to go to your scatter and put 100 million points in there to get a lot of density, which is a great intuition. Except that the Voronoi fracture, if you do that, so now I only have 100, and if I put it up to 1000, you can see it starts to calculate and do a lot of things. And that means that I cannot use Houdini because it's doing something which I don't like. So I found a nice hack, but at the same time, I want you to see that it does create more density. So the problem is that this geometry has a lot of points, right? It's actually quite nice already. So what we want to do is the Voronoi fracture is actually mostly caring about the outline of our object. It's going to try to fracture the object based on the outline. So what we can do, this is a new node that I tend to use more than the remesh node. This is quad remesh, and by default, it's going to still generate quite a lot of points. But you can set this all the way to 100, and so you can see a very, very light geometry now. But if you put that in the Voronoi fracture, and on a polypath and put like 100 times more points. So going to take a little bit, should be a lot faster. Let's see. And maybe 100 was a bit much, but okay. It's quite dense, but this is so beautiful. I could, again, like this is half of my artistic journey is zooming in to how good Houdini is creating this kind of very organic pattern here. Okay, I'm going to take off 1 0 because it was a little bit too much. But you can see that it calculates it so much faster. And so you can see that where the bones are, basically, and it's more dense, and then compared to where the bones aren't. But in reality, what you would expect is the opposite, where the bones already have the structure, giving the structure to the space around them, but then in between those bones, you need to have a different structure, this sort of cell pattern to generate the strength of the leaf. So what you can just do is to click on this button here, which inverts, I think should work. Yeah, and so now you get this very beautiful shape where wherever there is a bone, it's not very dense, and then whereas sort of the shape in between those bones gets connected by this pattern. And I think actually we can, if you just run this generate line fall off, make sure that this is visualized, I think we can actually make it quite a lot smaller. I think it would look better. Yeah, so the smaller this is, the more you get this kind of patterny feeling, like the structure is taking over, right? So it's like this leaf is trying to connect itself, the tissue of the leaf is trying to stitch itself together. And then one other tip here, if you go to the scatter and you increase this relax iterations to maybe 100, you'll get a much more even grid, right? So this is 1 scattery, 500. And it takes a bit longer to calculate, but it's a much more even grid, which I think looks really, really pretty. And again, so these are 10,000 points you can make. You can go up to whatever number your CPU can handle. But yeah, and if you make them smaller, they still look quite nice, I think. Even this shape, really quite beautiful. All right, great. Most of the sort of model building we've done now, but what I want to do is to convert these into textures. So that's the next step. I think everyone using Houdini should develop their own artistic tools. I talked about it in the last session as well. I think I just try to look at nature and then try to see if we can get something very close. And the trick is just to generate these attributes based on several orders of growth, right? So you can imagine that this leaf is, the skeleton is growing, and then in between the skeleton, something else needs to fill up that space. And using this Voronoi pattern, it's you can create something quite organic. All right, great. So we have our nice pattern over here. Let's put a null under here and call it cell pattern. So this is great. You can use a polywire if you want to render this, or you can, most render software can also just render these curves. But if you put this polywire and you make the joint really very small, do I don't have any light in here. Let's see. Yeah, so now they're real 3D objects, right? So this is how I used to render everything, which my computer definitely didn't like, because these are, yeah, almost 1,000,000 points, right, for this pattern. And so you can imagine like creating one leaf is cute, but what if you need thousands? What you would do usually is that you would turn all of these models together, you would merge them together and turn them into an instance. So you can instance them on a branch maybe. But what I found is that the problem with that is that once you've instanced them, you cannot deform them anymore. And when I'm generating my leaves, again, because I'm looking at nature, I don't want to pre-build my leaves and then copy them to the branches without having them react to each other or without having a lot of control over the shape. So what I want to do is to type of control, like this mountain control here, right? So if we just increase the amplitude, it might look a bit weird, but I want to be able to increase this amplitude here. This is officially too much, but I want to be able to deform them after generating everything. The way to do that is to just make sure that the geometry that you're using is very light. So you saw this quad remesh geometry over here, really very few points. And if you can then deform this shape over here, which then allows you to make thousands of clones, very light geometry, and then deform them. But then you lose all the detail of this nice cell pattern that we just created. So how do you get both? The way to do that is to use Houdini's new Copernicus system. So that's what we will be using to create the different textures for our very lightweight geometry. I basically use sweep for just about everything. I would say the polywire is just has less features than a sweep, and that might be useful if you, in the last session, we used the polywire to generate the geometry to deform the different branches. And I think that I tend to use a polywire if I just need something very simple. Like I don't want it to generate all kinds of texture, all kinds of UVs and things. although I think it might actually generate UVs. But does it? Yeah, I think it does. Anyway, I think that the polywire is, I just wanted to use it now because it just creates a very simple shape. But yeah, I think most of the time you would use a sweep to generate these shapes here. Yeah. Right. All right. So what I want to do is to basically use these textures here, use the shapes, 3D objects, right? They're not textures yet, and turn them into textures. And the reason why I want to do that is because this would be so good if this would be a bump map, right? Or this one, if you could use that for a bump map or a subsurface scattering map where everything that's thicker here lets in less light. The same for this. All of these little details, they add so much to the experience of the model. But again, right now, these shapes are quite high resolution to render. So we want to bake these shapes into textures. And we can use the new Copernicus for that. So what I want you to do now is to add an COP network. And I'm just going to call this leaf texture generator. And now I'm going to use my double screen. You might be wondering when it's going to happen, but it's actually now. So what you can do is just drag this into the second screen over here and then press F to focus the last node. And right now you can see if I jump into this network, then the rest of the shapes all disappear. And then if I would put this in the first screen, then you can see only this one, but you don't see what is happening in this leaf generator. And what you would have to do is then merge them together, and then it gets annoying. So that's why you use two screens. So this is usually then when you're working on the parameters of the models, and then maybe in the Copernicus network, you're generating the textures. That's why we use those two screens. Okay, let's just dive in here. So what we want to do is to import our geometry. And to do that, we need to use a sub import. And before, when I was still beginning, I was always clicking on this use external sub and then dragging this null in here, which does work, but I found it's actually not the most efficient way of using this. So instead of doing that, what you can do is just, let me just call this get geo. And what you can do is just jump in here, right? So just double click on it and then you're inside. And what you can do in here is just import it like this. Again, getting this object merge. And you can just import it like this, and it has some advantages that I'll show you in a minute. Okay, let's get first our branches in here. Get branches, and you can just drag this null over here. Now we have our branches in there, and we can use these branches to generate the textures. And now if you go up one level, so you just press U to go up one level, then now it's here, right? This is the same thing as if we use this. But if you just create a standard COPS node, I'm just going to use an SDF shape. Anyway, when you run this SDF shape, you'll see that the orientation and the scale of the COP network is not the same as this branch here. And what I used to do is to transform everything over here and then load it in. But it's much better to me if these models here have their own world where they live in, and then all of the transformation and stuff happens here in Copernicus. So what I'll do here is just to double click on here. And actually, why don't I drag this one to the second screen for now, so that we can keep seeing this screen over here. I actually want to, yeah, so I'm just referencing this geo over here while running this SDF shape. So we want to fit this leaf into this square here. And the good thing is, because we started with a grid, we already know it's going to be a squared object. So we just have to go to our sub import here and create two nodes. First a transform node. Let's see, let's run that. And I think it was minus 90 in the x-axis, right? So now we have the right orientation, but we don't have the right scale yet. We used this node before, the match size, to put in here. And if you run that, it centers it, which is fine. And then click on this scale to fit. Disappeared. Actually, it's right here. Oh, yeah, but it's a bit too small, right? So you see our SDF shape is twice as big, and it's because it goes from, if I'm saying this correctly, -0, yeah, you can see it here actually. COP network goes from -0 to -1 to 1, and also in the y-axis. So we have to make sure that this also fits to that. And to do that in this match size, you can set the target size to 222, and now it should fit perfectly into that grid here. There are two ways of generating textures here. I'm just going to show you the simplest one first. You need a node called Rasterize Geometry. And if you put your geometry in here and run that, then it's going to scream at you because it says it cannot generate a triangle mesh. And that's because we're using lines, right? So it actually needs to have a geometry, like a polygons, I guess, to generate this texture here. And so if you go now, I'm just in the second screen over here. So if I put a sweep in here somewhere, see, oh yeah, and make sure that in the sweep it's set, the surface shape is set to round tube. Now we see something happening over here. And if you scale that down, you can see that our branch texture is being generated, which is fine. And this works. But to me, what you lose here is this nice soft gradation that we had with our mask from geometry. So you could do stuff like blur this and things, but once you start doing that, then you start to blur these edges as well, the different branches. So what I suggest you do is to use my technique, or at least I use my technique, and you're free to use it or create your own. Basically replicating what we just did with the mask from geometry. What we do, so I'm just going to delete this sweep here and create another first link. I'm just going to run these branches here. So our original orientation, right over here, and create a grid. I should by default have the right orientation and size, and make sure that these are, again, have a lot of points to work with. I'm just going to do 1000 by 1000. That's a lot of points, but we need to have quite a high resolution to make sure that all the attributes get captured properly. You could actually connect these to the resolution of the CopNet, but for now, this is fine. But if you really want to have the perfect resolution, you have these rows and columns need to be the X and Y from the COP network. But I don't always need that specific resolution, and it might be a bit slow for what we're doing. Okay, so again, geometry, oh, sorry, mask from geometry. I always mess it up in my head too. Geometry from mask, no, mask from geometry. And then, oh, the other way around, right? Capture grid and put a grid in the first input because we want this this skeleton to project itself onto the grid. Branches over here. It'll take a minute. Again, it's going to be very slow because we didn't do our trick yet, where we have to make sure that this is set to points. Now it should be a lot faster. Visualize that, and now you see that our branches are here. And again, we get the same issue as we had last time. Our branches actually don't have a lot of geometry. So what we can just do is put a subdivide in here, maybe twice, subdivided twice. This should not make things slower. Actually seems to be still very interactive. Yeah, and we get our nice fall off from here. I always find it hard to visualize in my head what the fall off exactly looks like. You can see some blurring over here. If you increase this, you can see it gets more blurry, but because it's red, it's hard for me to visualize. You can go to this visualizer here. Now it's called mask, and change the color here. But actually, what I tend to do is just create a color node like we did before, put it in here, and ramp from attributes. Let's just actually make sure that this attribute is called something sensible, like main leaf lines. Okay. And make sure that here in the color type it says ramp from attribute and also called leaf lines. Now you see a much better representation of the sort of gradation between these two. Yeah, and so now it's starting to look a little bit like a bump map. You can change the way, like how thin or thick these are this way. If we have enough time, I'll also show you another way to influence the sizes here. But yeah, and you can use this as well to shape your bump map. In real life, things never perfectly gradually taper off. That's a whole different topic for rendering. We can talk about it another time. But for now, what we want to have is this attribute over here. And so this is generate leaf line attribute. All right. And then if we just plug this into this transform we did before, then we should have our grid. And if we plug that into our color, we will see that our leaf lines are captured within this grid. And to show that here in this rasterized geo, all you have to do is replace this intrinsic alpha, which is just that sort of, it's going to try to generate an alpha map based on your geometry that you have inside. But because we're using our grid now, it's not, yeah, we see just a grid. But you can just write here leaf lines, and now you have our leaf lines convert to, right? So now we have our leaf lines here. So now it's not a geometry anymore. Yeah, so now it's not a grid anymore, it's a texture. It's a Copernicus texture. And just in case you don't know, the resolution of these are defined by this resolution over here. If you can increase it, I don't think we will see much, but yeah, anyway, you can change the resolution over here. Okay, so these are our leaf lines. So in here, let's go back to this. Let's use the second screen. I'm just going to hold Alt and click to get the cell picture. So yeah, so some smart people, I think I can just, yeah, cell pattern. So you can just go in here and type it in here. It should also work. Let's see if it worked. Get the right thing. I think so. Yeah. So here we have our cell pattern, but otherwise you can just go up 1 or 2 levels and then use that second screen method to drag the null in here. I hope that makes sense. Okay, so we have our cell pattern. Also going to subdivide a couple of times so that we have a lot of points. We just want to have, oh, actually, I think it also smooths it here, which I don't want. Just going to increase the crease. I thought I could do that in here as well. Maybe resample will work better. Yeah, yeah, okay, so yeah, resample is better in this case. We just want to have a lot of points so that we have enough resolution to capture the attribute properly. So I'm just going to do another of these, just copy and paste this mesh from geometry. And instead of plugging in the branches, I'm going to plug in our cell structure. And we're going to call this cell structure. And just to visualize that in this color here. So right now it's visualizing our leaf lines, but now we should be able to visualize our cell structure. And something is happening like that. Yeah, here you go. So now you have this also got turned into a texture, right? But it created a different attribute called cell structure. So now if you go up 1 level, and you can create another attribute here called this cell structure and turn it into a mono. That's not necessary, but that's the cleaner way of doing things. It's going to create 2 nulls. One is our leaf lines. Right, that's this one. And then another one, just copy and paste it. Cell pattern and drag that over here. And now we have them separated. This might be a bit too big actually. Not as fine as the other one. Medium thinner. Yeah, that's nice. And you can see, like, that's what I really like is that you can see that. Can I put them next? Okay, oh, yeah, you can blend them. Sorry. You can use a blend node to blend these two together. Click on the foreground. And then in the mode, set it to screen. You can see that this is the part that I really like, is that you can see that our skeleton it really feels like it's giving a structure to our model here, like our leaf. And I showed this on Instagram, like if you or the other way around, maybe it's more visually exciting. You can turn it off and on. So I really love this feeling where if you start to render this, it will be plausible about how this model was grown. All right, so these are the Copernicus nodes. Of course, you can do many things here. You can give them colors, or you can display, maybe the spacing is not a great idea, but you can use a lot of different textures to different operators to make this a more dynamic object. These are the sort of the ways to extract the different models from our leaf model. We're not done yet because I see some things that will really make me very sad. Number one is this line here. You can see, and I wonder if you, I hope you can tell. I'm just going to switch them around. So you can see that the skeleton here is not reaching all the way to the end. We wanted to clean up that line, and because of that, we kind of cut off a bit too much. So it doesn't reach all the way to the edge here. So when you use it as a texture, you have this gap here. And those are the type of things that make me very sad and depressed when I see a texture doesn't quite line up exactly to the edge. So let's fix that problem right now. I'm going to go up a level and find our lines after our proximity, which are these. And so what I want to do is to find the last point here of these lines and fuse them with these lines over here. So you can see that they're almost reaching, but because we deleted some of them, they're not quite reaching. So I want this one to get married. I don't know, to me that makes sense. But I want these to meet each other and connect. And so what you would do is use a fuse node. And if you run that, then increase, oh, sorry, I put our points in here. in the second input of the fuse node. I'm just going to reference the blast here so you can see the difference. And then you would increase the snap distance, and then eventually they start to connect. What happens when you do something like this? Oh, okay, so now we found the perfect snap distance, but then some of them are not connecting, and some of them might be connecting a bit too much, right? So what we want to do is to only make sure that only this point right here, the final point of this main branch of the first branch, gets chosen as a connector, basically. What I found is that there's different ways of doing this trick, but the one that I used in the last session, I'm just going to do it again because it's fun and I think it makes a lot of sense once you use it a few times. What I'm going to do is first split off the main branch here. So I'm going to first find this, what was it, the first branch, and then again delete non-selected. So we have these branches over here. And now I want to have the last point. And we have our trusted group expression node. And with that, you can generate groups based on, this is not technically a line of Vex code, I think. This is called a expression, so it's not, doesn't count as a line of code. So we still only have one. I'm just going to call this group name endpoint, because what I want to do is to generate the last point of this curve here. And there is this preset here, this expression over here, which says the first point of primitive. And then if you make sure it's set to points, zoom out, it's selected points here, but the first one and not the last one. And we had this sort of fun interaction last time where I'm sure that there are very smart people who are able to have a perfect expression. I think David had a perfect solution, but I'm not smart enough. So what I do is I just reverse the line, inverse the line. I think it's a good way of thinking about it. And now they appear. So now because the first point is the last point is the first point, and then I just reverse them again so that they are now going the right way again. I wonder if you see it like this. No. Okay. This is my hack to creating the endpoints, and I will show you that how much I like my hack is that I again made a tool, the This Is Real Curve Endpoint tool, not for sale because of the proprietary technology that's in here. And if you go inside, you will, oh, sorry, you have to first allow editing of contents. If you go in here, you will see the perfect reverse first point, which is the endpoint, and then reverse again. So that's all this is doing. But in my projects, you will find this tool very often. Okay, so that worked. I have now an endpoint. So I thought about different ways of now getting this group back into our model. And I'm just going to show you two different ways, which in this case, I think you can use the more straightforward way, but I'll just show you two different styles of doing this. And because I blasted, I'm going to change it a little bit. Instead of using a blast node, I'm going to use a split node, because what that allows you to do, and I'm just going to make sure that this copy and paste this first branch, right? If you put it in here, it's going to do the same thing. It's just going to split off this branch. And then on the other side, I'm just going to use a node to visualize that. The second output is basically the rest. So the other branches without our first line here. And so what you can do when you finished getting that group, you can just merge these two back together, and then you have your group back, your middle line back, but now it has this endpoint group in there. Yeah, and then if you put that into the fuse here, and then in the group, make sure it's set to this endpoint. And I think now you still have to increase it. Oh wait, I thought maybe it's this closest target point. Yeah. Okay. So there's these different settings here, and there's this closest target point. And that now if you increase it, it's just going to snap to the first point that is the closest to it. Right. So now you have here exactly to the edge of our shape. Right. So that's how we fix that. So let's see if that works in our texture as well. Things still lined up properly, I think. And see. And now you should see that these lines are at the edge of our points, at least most of them. Yeah, so that, just like with everything, there's probably a few more ways of doing this and cleaning it up a little bit, but I think we are basically most of the way there. Some of them might overlap, extend a little bit, but that's actually okay. And I'll show you why in a minute. Okay, but now they're connecting, right? To the edges. I hope That makes sense. You just find the last point of that curve and then fuse them together. All right, cool. And again, like this is all procedural. I just want to make sure that everyone keeps that in mind, where now instead of doing this 180 alternate, so maybe, and I'm doing this opposite. So now you have the opposite curves here, and yeah, alternate actually quite nice. And you can play around with the way that these curves are being grown here. Tropism maybe can be turned off actually, right? And things should, most of the time, should work out quite well. You might have to nudge them a little bit here and there, but most of the time these skeletons should be generated quite well. And the skeleton, but also this cell pattern. So this also gets generated properly based on the skeleton lines. Great. Yeah, and actually, what's funny is that these edges here, I don't mind, because if you look at leaves, I made this project a while ago where you have leaves with holes in them, where the cell, where sort of the skin of the leaf is eaten away, and it reveals the cell pattern under the leaves. What you would see is in nature is that sometimes these sort of the walls of the leaf still are intact, even when the skin is gone. So you would have sort of these holes, but still have the walls of the leaf being intact. And also, I don't know about you, but I actually really like these holes that are being generated sometimes because of all the different thousands of points that we have. Yeah, anyway. Okay, so we generated these Copernicus textures, but so what can we do with those? So the goal here is to generate textures that can be used on low-res geometry. So I just drag this over here, right? And this screen is going to get these because we're going to merge them. So we want to use this as a texture. So let's see where is our leaf skin? This one, I think. Sorry, I'm just going to have to make a null, clean it up. By the way, the reference file that you can download after watching this will have a much more clean setup, where nice colors and cleaned up scene. Okay, so it's going to create a null here, and I'm going to call it leaf skin, and also going to do this object merge. So they are the same color, and take it in here. Get leaf skin. So when I'm running this, I get the skin of our deformed leaf with many points. What is nice about this object is that it has a UV map already. So let's use this UV map to actually show the textures on the model. And I'm sorry to have to say, but this is where me using a Mac is a limitation for now. Next week, there will be the Houdini 21 announcement, and I very much hope they fix this. I'm just going to show you what happens on my screen, but you can use a much better node. I'm running this blend here. So you have this node, preview material, and in that preview material, it basically creates, as it says, a material that is mostly useful in the viewport. It has all kinds of cool tricks, like you can use the bound map and subsurface scattering and specular and all these very cool features. So let's try to put this in the base color. And with me, if I put the geometry in there, I think it turns black. So that's not great. And the reason is because the Copernicus uses a new render system called Vulkan. And as far as I'm aware, it doesn't work on Mac quite yet. And I very much hope it works in 21 because it's a real limitation. And because I'm not able to create this kind of nice preview material that is then also usable in Karma. So I have to use sort of a workaround to get this, to be able to show you this. But you should be able to just plug your textures into these things like as you would in a standard render software, and then it should work. But with me, it doesn't. So I'm just going to delete this. And you can hopefully, if you use a Windows machine, then you should be able to use that and it should look much better. All right. So what I want to do is to use this texture on this piece of geometry here. And I have to use this UV quick shade to get it to show up. So when I run this, what it does is that it basically takes a texture map and projects it very simply on the model here. And so what I can do is to drag this blend over here. Doesn't work yet because first you have to write OP and then what do you say? 2 points. And if you do that, then it's going to show up in your model. The UVs are not looking great anymore. And that's because we have deformed the object, and the UVs that the textures that we generated after are based on the deformed object. I hope that makes sense. So we basically, and the UVs that are on here are still from the grid from the beginning. And because we then deform the object, generated textures, and then try to reconform that to this object, they don't quite work. So what we need to do is to generate a new UV map that is, again, the square grid. So if you can do again like the UV project. Oh, actually, I'll just show you the faster way of doing this. You can just copy this one over here, the base UV, copy that and paste it over here. And now you should see that now it does line up. Right now it lines up perfectly. At least it lines up as well as on the other objects. Right, so now we have our, my points are quite large. Yeah, so now we have our our texture on our object, right? So we're getting closer to our perfect setup. But so this is how I have to project the texture on my model before I send it to Redshift or Karma or something. Yeah, so anyway, so this is great, but we still haven't figured out, fixed our problem with our many points, right? 90,000 points might not seem like a lot, but if you have 200,000 leaves in your scene, that it does actually add up quite a bit. So what we want to do is to remesh, but I like to use this quad remesh object. It's a quad remesh, and again, make sure that it's set to like only 100. I think that's fine. I know my points are very small. Yeah. So very light geometry, right? If you look at the wireframe, super light geometry. This can work in everything basically. And again, you just generate the UVs just like on the leaf in the beginning, and everything still works. So this allows you to generate very high resolution textures for the bump map or the color or the transmission or the roughness, and use that very high resolution model that you created before to drive things like a bump map or other features, right? But the difference is that this model here, where's my information? Where did it go? Okay, because it disappeared. I'll show you in a different way. You can see that here we had 90,000 points, and here we have 130 points. But the quality of the texture is still high. We can, of course, add a lot more detail here, but the texture is really high. And then what we're going to do next is export this and create variations. But yeah, I just want you to understand sort of the workflow here, where in the beginning we just started with this simple base grid and projected the very flat UVs on there and generated our lines using the tree branch generator, right? Our very simple 3D texture almost. And then we use the UVs to conform those over here. Let's make it red. Conform those to the shape of basically our grid that is now being shaped by this leaf shape generator over here. All right, and you can play around with it. I should work quite well. Then once that is conformed, we clean it up with this nice trick over here, where we select the nearby points and delete them. That makes it so that our branches don't quite reach the edges of our leaf anymore. We fix that over here, although I think maybe in this setup, no, you need it. So just make sure that they reach the edges. And then we create a cell pattern over here as well, based on this Voronoi fracture technique. And then we use that in Copernicus to generate textures, and that gets applied to very low resolution objects. So if you do a workflow like this, and so let's say you're working on an interactive project, then suddenly your very nice looking organic models are usable in things like Unreal or Touch Designer as well. But you can export these textures and still have this very nice quality using the textures, right? And everything is generated in Houdini until you export it. Let's see, what does a watermelon leaf looks like? Yeah, so this is a perfect question, and the answer is yes, basically yes. So I'm building a quite simple shape now, but I don't know if, I don't think we should get into it right now. It might be a bit distracting, but basically whatever you're doing here with your deformation will make sure that these lines will follow the shape. So yeah, just wondering if what is a good way of showing this. But yeah, the dream here is to build a system where you can freely modify and deform this shape over here, and then the lines will just follow it properly. So you might be able to see a little bit in this mountain here where you change the element size. Yeah, I'm not sure if I'm going to be able to create quite such a nice, oh, it's opening, quite such a nice shape as the watermelon leaf. Let's see. I think I'm referencing a note here somewhere. I think I'm referencing another note, so I was trying to do something overlapping somewhere, which might take a while. But yeah, the idea is to do exactly that. If you go to my Pinterest, there's a lot of leaves there. Let's see if Houdini gets back to us or if we have to restart. But if you go to my Pinterest and to my nature references, I'm always looking at complicated leaves or interesting leaves, like shapes like this. Yeah, you can imagine copying something to the end of the curve, just like how we did the fuse technique over there, right? And so this should also work. And we have some more, and you also have these maple, I think maple leaves. That was something I was working on by myself, where you have this very nice spiky shape. I tried it with that and it works with that. And also it would follow all of these contours. So I would say try it out. I think if you can get to a shape like this, it should work very well. And I don't so the issue is that you need to get from your grid to that shape. That's the hard part, right? So if you have a grid going to a trace, if you're able to transform the grid to that trace, then it should work. But otherwise, you would have to. So that's why we do that deformation step. I think there are probably ways of doing that. The dream here is to be able to create very complicated, oh, a beautiful AI image here, a very complicated leaf geometry, and then have the lines follow them properly. So yeah, I would say try it out, and I almost guarantee it perfectly works, and otherwise you might have to do some tweaking here and there. And so that this, you can see that this is a reference of one of my posts with leaves. Because yeah, yes, L systems sound like they make sense, and I wish they did, but in my experience, the L system in Houdini, as of right now, is very slow and not very easy to control. So I think I spent at least 2 months of my life figuring out L systems and turtle codes. But what I run into is the same thing as with things like Vex, is that I'm sure that there are people out there who are very, very good at figuring that out, but I don't tend to use them. But one thing that we could do maybe is generate these veins which feel very similar to an L system. So L systems are something that you think about when you think about growth and plants, but in my experience, they don't really work for my projects. If you are able to make them work, that's great, but I have not been able to do that. But make sure that you try L systems as well. So the only real limitation here is that the grid and the lines need to be quite flat. Otherwise, the UVs don't line up. But to put a finer point on how much you can deform this, if I just put a bend here in between, and I change this bend angle, -5 again, right? -5 and 10. So this is a real 3D shape. Maybe I was the only one who was shocked by this, how well it works. But this, yeah, it's a real 3D shape. And probably other people are listening to what are you talking about? But yeah, so these are being deformed in 3D space as well. I'm just using it a 2D space because I want to generate textures, right? But of course, you can do many things here which allow you to copy things on a shape before you deform it. And you don't want to use a point deform. All right. So we have over here, we have our textures, right? We have our main vein, and then we have our leaf pattern. I'm just going to go over really quick how you can get a little bit more interesting shape over here, because it's a bit basic. And to do that, I'm going to get my branches over here. This is where a sweep node will help. I'm just going to get this. You know, there's quite a lot of points, but maybe it's okay. So what I do is that I just create this sweep node. By the way, if you use a labs curve sweep, it automatically puts a shape over it. And so what you would like to do is to change this fall off here. And it kind of works, maybe. But what you get is that suddenly these branches, they don't align anymore, right? I don't know if that makes sense if I make it a bit smaller. Yeah, so you can see because they start off all at the same thickness, they don't align to that main branch. And there are two ways of fixing that, and I'll show you both. First, I'll use a attribute remap because these branches are generating an attribute called a radius, which is actually set by the branches. So we'll go back to that in a minute. But you can just take the radius here and rename it P scale, which is the attribute that sweep uses. If you set that to 1, I think that the original branches, they don't have the right shape. But okay, starting to look a little bit more plausible. I'm just going to go back into our branches over here. And so when you run the lines, you won't see the thickness. So I'm just going to go to show you the mesh. You'll see that. See, this will line up very well with the sweep we had a minute ago. So if I go here to the radius and change the radius, -1, maybe not too much, -0.2, sorry, -0.7, a bit more thin, and then these as well, -0.5 maybe. And they always have this, by default, they have this mesh noise turned on for reasons that I don't really understand. So yeah, the branches have this mesh noise. Okay, so here we see a little bit better radius, right? Oh, I see that I'm actually turning them in the, I think when I did that here, not displacement, this one, there's I did this angle variation. So make sure that's turned off. Otherwise they start to point up and you might not get what you're looking for. Okay, let's go back into our Copernicus. So now you can see that the sweep takes the radius from the branches that we were just editing, right? And so now when you create this leaf lines attribute, see, that's showing us the template geometry. It's funny, it's showing us the ghost, the outline, because it's a bit still too, yeah. So now here, the reference group to primitives might probably work better, but then it takes a longer time. So I'm going to show you a different way of fixing this in a second. Yeah, so this is going to take a while. Yeah, I'm just going to turn it back to the points. So if you give this more points, no, maybe not this. But you can see that this middle curve here is it's too large to be captured by this leaf attribute here. If you increase the size, you get a bit better. Maybe, what about if you merge these two together, actually? Like the lines and the sweep. Yeah, there you go. So now it's getting the radius from both the middle line and the sweep. So this should look better. Still not quite. But yeah, anyway, you can see that you can change sort of the fall off here a little bit. Then one other way of doing this, when you use this sweep, is that you can also individually control this. When you have the sweep here, what you can do here in the backbone curve group, you can first say the trunk, right? So now it's just going to sweep the middle line, and maybe then these need more points. So you can very finely define each branch trunk, and then branch 1. And yeah, and again, that's nice about using these branch tools, is that all of these attributes and groups are being generated for you. This can be first branch, this can be the second branch, and then you can merge these together like this. Now in here, so I can make this maybe a bit bigger, smaller. That's right, it works, right? Yeah. You could even make two different, I would say, like the distance from geometry. This makes some sense. It's actually not doing exactly what I expected it to do because I merged them. No, okay, sorry. I'll have to, please look at my reference file. I did a better setup here, but the idea here at least is that you're able to have multiple of these generators here that generate different lines based on the thickness of the line. Yeah, sorry, but I think I chose the wrong node setup here. But if you look at my reference file, I'm just going to drag it down so you can see what that looks like. There's a bit more love and attention put into it. You can see that these are being generated separately. I hope that makes sense. So before we conclude, because time is running out, I want to show you how you can export all of this in a nice and sustainable way. And the way I do that is trying to find my leaf texture generator here, and is to not only use a Copernicus network. Okay. Oh yeah, one thing that might be a good idea here is to use an output flag here at the end, so that Copernicus is always picking up the right objects. So that should work. Okay. So we have our leaf lines and our cell pattern here. Okay, so we have our Copernicus network, where we can use another network called a top network. And the top stands for task operators. And what this can do is automate things like exporting your geometry and exporting your textures. So we're going to use that to both export our stuff, but also to create variations. So I'm going to call this export top net. This one is a slightly confusing network if you've never used it, but I will show you step by step. When you dive in here, you have just this node over here. And what you need to do is very similar to what we did before with the Copernicus nodes, is to get our geometry in here and to, so maybe not get our geometry in there, but reference certain parts of our network that we want to export. So one of the ones is the image output, ROP image output. This is used to output images, and you can see here it's looking for a cop path, and we have those. If we go in here, we have our leaf lines. You can drag it over here. Yeah, we'll go over the naming of this in a second, but let's first get the leaf lines in here and copy and paste. You can just connect these two together, leaf lines, and then the cell pattern, and drag it over here. And then we need to have our geometry output. And I also have a setup, if people are interested in that, how to do all of this with USD. But what I found in USD is that there are some limitations that are not really resolved between Houdini and Unreal. But if you're using purely USD workflows and you're interested in how that works with this topnet, then I made one of those as well. So you just reach out if you need that. And this one is export geometry. And the geometry that we want to export is our low res geometry, which we put over, where was it? Here. We put a null after our UV here, and we call this export geometry. And I just put it before this UV quick shade, because if you run a UV quick shade, it automatically creates a material which sometimes can get in conflict if you load it back in. Okay, and in our export geometry, you can just drag in the SOP path, right? The geometry. So now, if you would run these nodes, there's like a special command here. If you right click on it, it says cook this node, or dirty and cook this node. Also one of my favorite words in Houdini. So dirty and cook this node. And what it will do is it will export one by one, and which is great. But what we want to do is to use this to create variations. And I'll show you how to do that. And it's a node called a wedge node, WEDGE, wedge. And so what wedge does is basically just create variations. I think you have to put it at the top of your network. At least that's what I do. And what you can do here is you can create attributes in here that can drive parameters. I'll just show you. So I'm not just going to do 2 wedge counts, so 2 variations. And then in here it says the wedge attributes. So I'm just going to make one. I'm going to call this noise offset. And if you copy this, and if you create that, you can say a random sample. Yeah, and it's going to randomly go between these two values. Now we only have 2, so it's going to go between 0 and 1. Okay, wedge. So where do we use this noise offset now? So the way it works is that let's go to our geometry over here. I'm just going to drag this one into our second screen, because we need to have this over here, and go up 1 level and find our mountain noise here. So you can see that we have this offset here. It might be a bit too much actually. Maybe a bit less and a bit smaller. And then you have this offset here. So this offset does a pretty good job of creating random shapes, right? So what we want to do is to use this noise offset attribute to randomly generate parameters to basically adjust this. So what I can do in this case is just copy this, right? Just copy the words and type in here. Just do 1 times, like star times, and then you have to type at, and then the name is noise offset. And you can see something happen here. See? Oh, now it's 0 because it's going to start at the 0 here. I think if I just press this one and press generate here. So you see you have 2 little dots here. And if you press between them, you can see that it generates 2 different variations. And what I mean by variations is that if you go to these lines over here, and see, if you go between these 2 dots, it's also generating different shapes here. And if you go to our cell pattern over here, it's going to generate 2 different patterns. Yeah. So of course, you can make many attributes in here using this wedge. I'm just using this noise offset for now, but I have a setup where it's like the amount of skeleton arms or skeleton lines that are being generated, or the size of this noise here, or all kinds of different things you can pre-program here in this wedge sub. And then what you can do is to export all of these different variations. And to do that, I'm going to have to show you a sort of, the most important thing is that you name them properly. So what I'm going to do here, so I'm just going to explain how this works here. So here first is $hip. So that's the project file that it's the folder that your project file is in. Right now it would generate a folder called render, and it's going to put our EXR file in there. But what I want to do is to basically have this folder take on a different name for each generation, or for each variation, sorry, that it does. And I wrote down a little sentence. What is important, I'm just going to copy and paste and explain what's happening here. So what is going to happen now is that it has this, so again, this is the hip, the file, the folder where your project file is in, and it's going to create a new folder called export leaf. And then you have to type it like this, like there's this little shape, which is sometimes hard to find on your computer. With me, it's next to the Z, next to the Z button. Yeah, it's just one of those shapes that you never use. Let me see if I can find our chat here. Sorry, just gonna put it in here. And especially pay attention to that symbol before the at wedge num. That's if you type something, if you put an attribute in between those 2 shapes, what it will do is to, whatever the value of that attribute is, into a string, like into text, convert that attribute. So in this case, what it's going to do is that if the wedge num, the number of wedges, is the first one, it's going to be a 0. And if it's going to be a second one, it's going to be a 2. Thank you, David. It's called a backtick. I mean, with me, it's next to the Z button, but yeah, if you have to find it on your computer. Okay, so I'm just going to, so this is the main structure, right? And then it's cell pattern. And again, I'm going to paste that, except change this from main structure to cell structure. And also in this export geometry, also paste that, but just going to call it geometry. And I'm going to make it an OBJ, so .obj, which exports it as an OBJ. I'm just doing that too, so that I can quickly preview the object. But if you turn this into BGEO, then it will be that file type, right? And now if we've done everything correctly, we should be able to select this, right click and click cook node, and it should do something. So you can see that this is also a very beautiful shape. Just going to find this on my computer, and then it should work. So now in here, I have my network doing something. Is it this? Oh wait, I think it's I think it's in my temporary folder. Sorry. Yeah, it's in my temporary folder. Sorry, I didn't make a folder here, but I mean, it's okay, let's try that again. Right click. So if sometimes it doesn't export, then you can try this dirty and cook this node, but it will just basically delete all the attributes it generated before and create new ones. And now we should see here, when it's ready, that it should generate our folder. Let's see. And this is also the end. And so I hope this works. Yeah, here you go, export leaf. And it makes a folder 0 because it's weight 0. And inside is our main structure. And then this is some issue here, but anyway. And then when you go back, eventually it's going to create a number 1 as well. And inside it should export our main structure. main structure again. So this is the second variation. And then inside here already it created that nice cell structure. And then once it reaches this export geometry over here, it should also create a OBJ file from our shape. Let's see. I think that's supposed to work. So on all of these textures are generated based on this wedge attribute. So again, if you add more variety, if you add more attributes and more changes in these start and end values here, then it will work. So this is our object. On Mac, you can just quickly preview it like this. Oh, we double clicked it. Shouldn't have done that. Yeah, but you can see like it generates both the textures and the model. And yeah, then you can put this into Unreal and then load in these textures, and you can be fairly sure that they line up basically perfectly. But I just want to take your eye on the size of this geometry, is like 9 kilobytes, which is very small for an object. And you can make it even smaller, but this is what I settled on, which works very well for my setups. So here in this wedge here, it generates, so I defined this wedging number, like this offset value. So you can just copy that. And if you go back to your network, there was our mountain here, which I should probably call noise displacement. And I put it here in this offset value. So I just did 1, because if you do 0 times, then it might not be offset enough, but 1 times the noise offset. And so it's going to every wedge, right? You can see like these different variations if you look at this offset here. So the second variation is this number, and the second variation is another number. And so you can you can put this noise offset in our, let's see. I'm just going to see what's going to happen. Times attribute noise offset. Probably should give a little bit of a push, because if this gets too small, it might not work. Let's see. Now it's this number, and then I think maybe I have to regenerate, maybe not. Maybe it can and of course you can create much more, right? So you can make 15 wedge counts, just generate this again, and you should get much more variations, or the amount of this tropism times. So now you created all different shapes again, which get deformed. And this is why Houdini is so nice to use, because of this proceduralism. Like, I'm just going to keep putting noise offsets over here. And yeah, so this might be a bit much. That's what I was worried about. Something like that. Yeah, and so if you keep scrolling through here, it's going to generate completely unique objects. And all you have to do is, what I tend to do is this reflex, is that I just delete all of this export leaf object. You don't have to do that. And if you run this, it's just going to right now it's going to make 15 variations of your leaf with internal structure, with this cell structure that is all based on the shapes that are being generated automatically. I use this for my interactive project. So I'm building something in Unreal, and it was just this is my own personal mental blockage, is that I really don't like using bot models and textures. So I have this sort of obsession that I want to make sure that everything is made by me, or at least I know what's going on. And so this led me to this kind of workflow where I want to make sure that I can art direct all parts of the project. And now I can export a lot of variations and load them into Unreal. I put that in a particle emitter, and then you have 15 types of leaves flying through the air. And also those leaves are, because the geometry is so small, you can also curl and deform them a little bit. So you're not just working with instances, you're also working with real geometry that's being deformed with a very nice texture. It's funny because I have like a research period. These are all generated exactly as we just described. So you can see all of them have. The only part that's not here is the sort of eating away at the skin, which is just an alpha channel, right? That's also being generated based on some other things. And just to put another finer point on it, the material here is only using the Copernicus textures, except there's one horizontal line, but everything else is just Copernicus. There's no other textures here. So all generated. Yeah. So actually I think the middle one here is maybe geometry. But now my display maps look much better. But from a distance, a bump map would be fine. Yeah, thank you very much for watching and for your attention. And again, if you have any questions, you can put it in the Discord channel for this group, or you can reach out to me directly on Instagram. It's also fine. Thank you, Houdini.School, for having me, and I'll show you our many variations here that is generating in the background. Oh, now we have already 8 of them. So this is something, oh, see, you have to make sure that all the values keep working. But anyway, this is something that you would like to do. This is rendering objects, rendering textures. Yeah, and if you have a lot of CPU cores, it actually, you can see that it's not one by one, right? It's like it's doing many at the same time, because I have quite a lot of CPU cores. So the more that you have, the more they can do at the same time. And if you have enough RAM, then it can actually go really fast. You can do multiple particle simulations at the same time this way as well. But that's for another course. Thank you.